Alright, we'll now have a look at how we can form a standing wave by disturbing a string so that a continuous traveling wave travels towards a fixed boundary and reflects and interferes with itself, really. So the reflected wave interferes with a wave that's still incident on the boundary. Let's have a look at what that looks like. So here we can see we're creating a continuous up and down disturbance on the left end of the string, which causes a continuous traveling wave, which is the red wave here, to travel towards this boundary. And so this wave is represented by the red wave. What's going to happen at the boundary is we're going to get an inversion of the wave and reflection. We're going to have that represented by a blue wave traveling back in the opposite direction. So I'll just slow this down while it's happening. So here we can see the first part of the wave is just about to arrive at the boundary, and it reflects and inverts, and the reflected wave interferes with the incident wave that's still arriving at the boundary. And that interference results in a kind of cancellation of parts of the wave, so they're interfering as per the principle of superposition. And we'll just speed the animation up again. And what we can see is as the returning wave, the reflected wave, interferes with the incident wave, we have the conditions required for a standing wave to be set up. And you can see that we get this pattern of stationary nodes and antinodes along the wave. And we have a standing wave, which is this black wave, which is just the superposition of the two waves of equal amplitude and equal frequency traveling in opposite directions. And because of the phase change that happens at the boundary, we always end up with a node at the fixed boundary. So that's a boundary condition for a standing wave on a string. If we have a fixed boundary, the two waves will always interfere destructively there. As you can see, the blue wave is always exactly the negative of the red wave. And so that means that there will never be any displacement at the fixed boundary, and so we will always have a node there.